this video, we're going to be using the empirical rule and Chebychev's theorem to interpret standard deviations. So the empirical rule is also called the 68, 95, 99.7 rule, where these are the percentages here that are within plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. These are all percentages here. What percent of the data by observation? That's what empirical means, is by experimentation and observation. So 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean. So use the empirical rule. The mean of a sample of vehicles along a stretch of highway is 71 miles per hour. What is the standard deviation, or with a standard deviation of 3 miles per hour? So we have x bar is 71, x bar minus 1s is 68, x bar minus 2s is 65, x bar minus 3s is 62, x bar plus 1s is 74, x bar plus 2s is 77, x bar plus 3s is 80. Estimate the percent of vehicles whose speeds are between 65, which is here, and 77, which is there, plus or minus 2 standard deviations. That's 95%. Using the empirical rule. The mean value of land and buildings per acre from a sample of farms is $1,600. This is from a sample with a standard deviation of $100. Data set is a bell-shaped distribution, meaning we can use the empirical rule. Assume the number of farms in the sample is 78. Use the empirical rule to estimate the number of farms whose land building values per acre is between 1,500 and 1,700. So that is going to be 1 standard deviation to the left and the right. That's going to be 68%. And then 68% of 78. So 78 times 0.68, 64, 56, and 6 is 62, 0, 48, 42, and 4 is 46, and 4, this is 8, and 6, that's 14, 6, and what was this? Another 6, so that's 12, and then so 52 point something, right? And they just said, let's round that up to 53. Just open my calculator here, verify that 68% of 78 is, yeah, 53.04. Let's not do that by hand. 53.04 is going to be 53 when we round it. If 30 additional farms were sampled, about how much of these additional farms would you expect to have land and building values between there and there? So we want to find 68% of 108 is going to be 73.44, and then minus the 53.04 from before is 20 roughly, that we're going to 20 more farms that we would expect. The mean value of land and buildings per acre of a sample of farms is 1,600 with a standard deviation of 300. The data set is bell-shaped. Use the empirical rule to determine which of the following farms whose land and building values per acre are given are unusual. Unusual here meaning more than 2 standard deviations from the mean. Are any of these values very unusual, more than 3 standard deviations from the mean? So 2 standard deviations away, minus 2 standard deviations away. That's going to be the first thing that I'm looking for here. And then this one is going to be minus 3 standard deviations plus 3 standard deviations. So let's just figure that out with a calculator here. 1,600 plus 2 times 300 is going to be 2,200. And let's re-enter that, but change that plus to a minus. And we get 1,000. So everything between 1,000 and 2,200 is okay. While we're at it, let's figure out 3 standard deviations. Let's come here and make this a 3. And that's going to be 2,500. So anything more than 2,500 will be extremely unusual. And anything below 700 will be extremely unusual. So we'll start answering this question here. 610 is extremely unusual. See anything on the high end there? Nothing seems to be on the high end there. So now we're going to look for things that are less than 1,000 but above 700. Actually, anything less than 1,000. So there, we'll classify that there. Anything above 2,200 here would also be unusual on the high end. So that's that. That's how they wanted you to answer there. Anything below 1,000 or above 2,200 in the first question. Anything below 700 or above 2,500 in the second question there. I believe that's everything. Yeah. So we'll come back next time and we will start talking about 2.5. See you for the next video.